Hello friends, in the last lecture we have talked about direct addressing mode and immediate addressing mode and indirect addressing mode. Let's just take one example about indirect addressing mode. I think it's a bit confusing for you. See, uh, let's think that A is your data and its value is, let's say, um, this is actually your address. Okay, let's say this is 400. Okay, this, so at 400th location, so this is 400 number location. At this location you have another address. Let's say that address is um, mm, 200. Okay, so this address here you have 400, and here in this location you have saved 200. So that is again an address, that's not the operand. Okay, so at 200th location, so the your control will go to 200th location and access the contents at the 200th location, and see here is your actual operand. Then that operand will be fetched and it will be stored in your memory buffer register. Okay, so you cannot directly get the operand from this address. That's but you can get the address of operand from this address. Okay, remember, address of address. That's why this is called as indirect addressing mode. Now our next addressing mode is register addressing mode. See, sometimes what happens is we don't have to, the control doesn't have to go to the main memory. It can directly fetch the operand from its registers, processor registers. So from which processor register the operand should be fetched, that is defined here. The register is defined here, the address of that register, and at uh, from that register that operand is fetched. Okay, and then that operand is processed according to the instruction which is given here. Okay, so it is just specifying, it is again just specifying the address of your operand, but here the address will be one of the registers. And see, your registers are very few in your processor. I think there are only 6 to 7 registers, or maximum 32 registers. So it depends upon actually the processor, how many registers will be there. So that's why this section is smaller. Just look at the instructions format. See here, opcode is small, operand is greater, number of bits. Opcode is small, number of bits, address is greater. But here, this instruction is greater, and the number of bits for specifying register are very few because there are very few registers in your process. Okay, so it's same as your direct addressing mode. Here only the difference is, here you are specifying address from a memory, here you are specifying a register from your processor. Okay, now again same thing, register in direct addressing mode. So here in this register, from in this specified register, you will get the address from which you have to fetch your operand. Okay, so let's say we have specified second register. Okay, first and second register. On second register we have address, let's say, 500. Okay, so this is my address 500 here. So at 500th address, so it will count 0 1 2 3 up to 500. At 500th location the operand will be stored, and that operand will be fetched, and then again it will be stored in your memory buffer register. Okay, so it is again same thing like indirect addressing mode. Only difference is here you are not specifying an address from a memory, we are specifying the register from one of the processor registers. Okay, now this is one of the important addressing modes. This is your register. This is your displacement addressing mode. See here what happens is the main thing to remember about this is you are uh, you are going to calculate your address, okay, and in the base uh, here you are only going to specify the base address, and here you will specify the displacement. Okay, so let's say my base address is uh, 20. Okay, and here I'm going to specify my displacement. So displacement will be, let's say, 5. So this 20 plus 5 will be 25. So I have to go to 25th location. And if you want to specify another address, you just have to change this displacement. So let's say if this is 7, the base address is same. So this will be 20 plus 7. So at the control will go to 27th location. See, this is useful because you only have to specify or you only have to increment the displacement. See, if this is actually useful when the instructions are being executed continuously from your memory. Like if your instructions are stored at let's say location 101, 102, 103, 104, then you can just specify the base address as 100, and you can specify you can just increment the displacement. Okay, and the displacement will be 1. So see, think about the memory we are storing here. You don't have to specify 101. So for specifying 1, uh, you can only use 4 bits or 3 bits. Number of bits becomes lower to specify lower numbers. That's why this is very important, displacement addressing. Okay, here you have to calculate the address. The base address is specified, and the displacement is the only displacement will be changed. The only displacement will be increased. Okay, and that's how you can calculate those addresses and fetch the next instructions. And last one is stack addressing mode. So here, if you are using a stack, this will always specify top of stack register. I hope you know what is a stack. Stack means first in, first out structure, right? Uh, First in, last out. Or you can say last in, first out. You can take anything from the stack from only top of the stack. So this will specify the address of top of the stack if you are using stack addressing mode. And for specifying these addressing modes, there are these we have just seen 7 addressing modes. For specifying these different 7 addressing modes, we'll need minimum 3 bits to specify the addressing modes uniquely. Okay, so that was all about addressing modes. We'll stop here for today. We'll see our next part in our next lecture. Thank you.